This is the concept of operations for the shell system. It consists of two main hardware components. There's a propellant depot capable of storing both xenon and hydrazine in large masses in geostationary orbit, and propellant transporters that take these propellants and move them to the clients who will be refueled. The propellant depot is launched directly into geostationary orbit by a Falcon Heavy, and similarly, the propellant transporters are launched directly into geostationary orbit by a Falcon 9. We will also be considering the Starship launch system if it becomes available. The depot remains stationary in geostationary orbit throughout its entire lifespan. The propellant transporters are responsible for moving the propellants from the depot to the prospective clients. These refueling operations consist of a propellant transporter beginning docked with the depot, filling up on the next client's propellant choice, xenon or hydrazine, and then phasing through geostationary orbit to that client. When the propellant transporters reach the client, they will use our docking and refueling interface to transfer propellant to the client. And when that's finished, they'll retreat from the client and begin the phasing process back to the depot, and the cycle will repeat. The duration of this entire operation depends on the level of demand we are supporting. But at what we anticipate to be the optimal level of demand for a propellant transporter to support, we anticipate this process will take 120 days. As the depot progresses throughout its life, it's going to be emptied gradually, and before a depot is fully depleted, a replacement will be launched. The depot will be disposed to a graveyard orbit 300 kilometers above geostationary orbit. The duration of a depot's lifespan also depends largely on the demand. Earlier on in the business, when we are anticipating a lower client base, the process could take up to 7 years. But as the client base expands, we're expecting that to be brought down to almost 2 years.